This conference will now be recorded.
Hello everyone. Today we will discuss only problems, and this will be the last class related to chemical kinetics. The first problem that we have here. Half-life for 32 phosphorus given, which is 14.3 days. And we have to calculate specific activity, and it should be in the unit curie. For a sample of phosphorus, now this sample of phosphorus is containing 1 part 32 phosphorus per million parts of phosphorus. Okay, so the isotope of phosphorus, which is present in higher percentage, that is actually 31 phosphorus. And when we are considering 32 phosphorus, this is actually radioactive. And if we consider that there are total 10 to the power 6 31 phosphorus atoms are present, so out of this 10 to the power 6, only one will be 32 phosphorus. So that is mentioned in this way, that containing 1 part 32 phosphorus per million parts of phosphorus. Okay, this information is given. Atomic mass of phosphorus, that is the phosphorus which is present in higher percentage, that is the maximum abundance, that is actually 31 phosphorus. But here the phosphorus that is present in very minute amount, that is 32 phosphorus. Okay, so these two are isotope of each other. And here, according to this information, we have to find out specific activity in Curie. Now, specific activity, we have already seen what is it. It is as activity per unit quantity of atoms of a particular nucleotide. So it may be per gram or it may be per kilogram also. So per unit quantity, that is the important thing. So this is the definition of specific activity. And what is Curie? Curie is Ci. And Curie, how it is related to disintegration per second, that means dps, it is 3.7 into 10 to the power 10 dps. Okay, so these two information we have to apply. First we find out that one atom of 32 phosphorus is present out of 10 to the power 6 phosphorus atoms. Okay, now when we are considering 31 phosphorus, we can say that 1 mole 31 phosphorus should have mass 31 gram. Okay, in reverse way we can say that 31 gram phosphorus, that is 31 gram phosphorus, that will contain Avogadro number of atoms. Now Avogadro number is 6.023 10 to the power 23. Okay, so 31 gram, that is the mass of this number of atoms. Now if it is 1 gram, then what should be the mass? The mass should be Na divided by 31. Okay, so that is 1 gram mass, that will be for Na by 31 number of atoms. Okay, now as it is mentioned that amount of 32 phosphorus in 1 gram phosphorus, that is parts per million, 1 part per million. This, from this we can write that 1 divided by 10 to the power 6 multiplied by Na divided by 31. So this is the number of atoms for which mass is 1 gram. Now in this number of atoms, 1 divided by 10 to the power 6 number, that is the number for 32 phosphorus atoms. And suppose this is capital N. Okay, and if we put the value of Avogadro number, that is 6.023 10 to the 23, after this calculation we will get the value of capital N 0.194 multiplied by 10 to the power 17. So this is the first part of the problem. Next we will see what is decay constant. Now decay constant, why we are calculating? Because after all we have to find out specific activity. Okay, and specific activity, that is equal to decay constant, which is nothing but rate constant. Okay, lambda into k, you can also write k into n, lambda into n. So that is why we need the value of these two. N we have already calculated, and next we have to calculate decay constant. Now half-life is given 14.3 days. So from that information we can easily find it out, because decay constant is related to half-life by this relation, which is applicable for first order kinetics, T half. Okay, so T half value is given 14.3 days. But remember, ultimately we have to express it in Curie, and Curie is equal to this amount of dps. Now dps is disintegration per second. That means here it is given in days, but we have to convert it to second. So that is why number of days will be 14.3. So with it we will multiply 24 hour for one day. So 14.3 into 24, that will be the total number of hours. But from hour we have to convert to minute, so it will be multiplied by 60, and from minute we have to convert it to second, so again it will be multiplied by another 6. Ultimately the value of lambda is 5.6 per second. So the unit will be per second here. Okay, and here the unit for capital N, this is actually the number which is present per gram. Okay, so we can write the unit as per gram. So now we know also what is the value of lambda. Next we will find out specific activity, which is lambda into n. Lambda value 5.6 10 to the power minus 7, and n is 0.194 10 to the power 17. Okay, now finally the unit will be dps per gram. So if we do the calculation, it will be, the value will be dps per gram. Okay, now dps per gram we have to convert from dps to curie, and for that we will divide it by 3.7 10 to the power 10. So these two will be cancelled. Ultimately the value will be 0.294 curie per gram. Now final answer we have in gram, but it is not here mentioned specifically that whether it is per gram, that is unit quantity, whether this quantity is per gram or per kilogram, but I will show you both. So 0.294 curie, that is per gram, that is for 1 gram. So when it will be 1 kg, that means 1000 gram, obviously the value will be high, and from gram to kg it is 10 to the power 3 times high. So if we want to convert it to kg, we have to multiply it with 10 to the power 3, and ultimately it will be 294 curie per kg. Okay, so it depends on that is if it is asking that express it per unit quantity of kg, then answer will be 294, but if it is in gram it will be 0.294. So we have to read the question carefully, in which unit actually it is asking to express the final answer, that we have to check carefully. Okay, so should I repeat it once more? Is it okay? Next problem. A flux contains a mixture of compounds A and B. Both compounds decompose by first order kinetics. Half-lives for A 300, for B 180 second. Okay, both are in second unit. If the concentration of A and B are equal initially, that is when reaction is not started, then the concentration of both the compound same. We have to find out the time required for the concentration of A to be 4 times that of B, and the unit should be in second, that is mentioned in the bracket, because if you look at the options, no units are mentioned. And here another information is also given, that ln2 value, which is 0.693, this is given. Now we can write that concentration of A at time t, that will be 4 times that of B. This condition we have to basically find out. Now AT, how it is related to initial concentration of A, as it is following first order kinetics. So this will be the relation, where remember this Ka is the rate constant for the compound A, that is for the decomposition of A, the corresponding rate constant is Ka. Similarly, when it is concentration of Bt, it will have relationship with initial concentration of B, same relationship, but here it will be Kbt. Now these two values, if we put in this equation, then what we will get? A0 e to the power Kt, B0 e to the power Kbt. Now it is also mentioned concentration of A and B are equal initially. So it means what? A0 equal to B0. So we can cancel these two terms, right? Now next what we will do, e to the power minus Kt, another exponential term. Now it will be denominator, and this is equal to 4. 4 we will write 2 to the power 2, and left hand side, if we bring both the quantity in same place, it will be plus Kbt, because it is in denominator. When you are bringing it in the numerator, it will be positive. This is equal to 2 to the power 2. Now we will take ln both sides. Okay, so when we are taking ln both sides, E will be cancelled. So finally Kat plus Kbt 2 ln 2. Okay, ln2 value is given, and this t, this actually we have to find out, because the time at which concentration of A is 4 times of concentration of B. This is Kb minus Ka, and this side it is 2 into 0.693. Okay, now Kb and Ka, these two, how we can find out? As it is following first order kinetics, we also know what is the relationship of rate constant and the half-life. Okay, so Ka is equal to 0.693 divided by half-life, and the half-life for A is 300 seconds, and similarly for Kb, both are first order, divided by 180. Now these two values we will put in this equation. So T, then we can take 0.693 common, so it will be out of the bracket. 0.693 multiplied by T, first Kb, then Ka, equal to 2.2 into 0. So see, here I have not done the calculation, because ultimately these two will be cancelled. Okay, so it is already simplified. Now T into 300, 180 divided by 300, 180 is equal to 2, and ultimately the value will be 'So can you tell me what will be the final answer? It will be in second because these two values are second, right? So Ka, Kb, these two will be second inverse. But as we are taking again, that is, this is again reverse. So ultimately the unit will be second. And this is equal to 900 second. Is matching with option 4. Any doubt? Should I repeat?
No, ma'am.
Next one. Here we have 4 reactions. A to P1, B to P2, C to P3, D to P4. The order of the above reactions are the corresponding orders A, B, C and D. All are small letter. The following graph is obtained when we are plotting log rate in the y-axis, log concentration in the x-axis. This is y, this is x. Now, here we have different orders for the values of A, B, C, D. So correct sequence for the order of the reaction, that is which will be greater than which quantity, that we have to find. Now rate is related to concentration, that is rate expression. We know it is rate equal to rate constant, then concentration of any species. Suppose it is, I'm simply writing concentration, to the power n. Okay, this is a general expression for it, right? Now if we take log both sides, it will be log rate log k and log concentration to the power n, but n as it is in power, so it will come before log. Next we have to compare this equation with y equal to t plus mx. Okay, here y is log rate, c is intercept, that is log k. This is intercept. Intercept means this value. Where the line is cutting the y-axis, this distance is intercept. M is slope because rest of the part is x. Okay, so if we compare these two equations, we can understand here slope is basically equal to small n. That means slope is nothing but order. Okay, now from the graph that is given, that is a picture that is given in the question, we can easily understand in which case n value is maximum. Fine. Now if we look at the lines carefully, this line is steeper among the 4 lines. This is steepest line, so that is why D will, that is the order for the reaction D to P4, this D will be maximum. And which one is minimum? It is C. Okay, so C is minimum because this line, it is almost close to this x. Now D at first, C at last. If it is the case, then these two we can easily cancel because in both 3 and 4, D maximum, C minimum. Now among A and B, B is steeper compared to A. That means the value of B that will be greater than A. So which option is correct? D, then B, then A, then C. Okay. So this is the values of order. That is maximum order is for D. That is capital D2P4. For the last reaction, it is maximum. For the third reaction, it is minimum. In the second position, we have this reaction, and at third position, we have A2P. Right? So here we have taken the help of this equation, rate equal to K into concentration to the power n. This is a general expression because n value may be anything, 0, 1, 2, 3. We do not know what is the exact value of order, and that is also not required. We just have to find the relationship, that is whether A is greater than B or B is greater than C, like this. Okay, so is it clear? Can I move to next slide? Here we have the question. Rate of a reaction which is biochemical reaction at physiological temperature, that means our body temperature. It occurs 10 to the power 6 times faster when you are doing this with enzyme. But when enzyme is not used, then the reaction rate will be less. Now we have to find out the change in the activation energy when we are adding the enzyme. So when we are adding catalyst, suppose then the rate constant K prime, and when we are adding no catalyst, I mean enzyme, then the reaction rate is K. Now the value of K prime, it will be obviously greater than K, because when you are adding enzyme, that is catalyst, rate of the reaction will increase. Now activation energy, if for the first one activation energy is E prime, for the second one it is E. Now activation energy, this is inversely related to K prime. So when activation energy is high, rate of the reaction is low, and when activation energy is low, rate of the reaction, that is rate constant, will be high. So here E will be greater than E prime. Okay, so when you are not using any catalyst, then activation energy is high. We have to find out change in the activation energy, that is difference between these two. Now E is greater, so E minus E prime, this value we have to find. Okay, now see, look at the options. These two are in negative, there is a negative sign, but option 2 and 3, these two are positive. Okay, so change in the activation energy, that is when there is catalyst present, because first it is mentioned faster with enzyme, then it is mentioned without. That means when it is without, that is no catalyst, that value will be in the second position. So it is actually E prime minus E, and E prime is lesser, so this must be negative. This is positive. Okay, so in the question it is asking faster with enzyme, that means with enzyme is E prime, without enzyme E. So E prime first, then E. So this difference must be negative. So you can easily cancel option 2 and 3. Okay, without doing anything. Now here we will take the help of this equation, Arrhenius equation. K is equal to pre-exponential factor e to the power minus Ea by RT. And if it is K prime, then K prime is related to K because K prime is greater than K. So see, 10 to the power 6 times of K, right? And here we have a prime sign because this is the equation when we are using catalyst. So here catalyst present, here no catalyst. Okay, now in place of K, you can put, that is from equation 1, you can put the value of K. Now when we are putting the value of K, it will be like this. AA will be cancelled from both sides. Fine. And there are two exponential terms. if we take ln, that is if we take, after cancelling this a, if we take ln, these two are related to each other as there is a multiple sign. Okay, so ultimately it will be plus. So ln 10 to the power 6 and ln base is e, so exponential terms will be cancelled. Prime is there, then e prime a, that is a, you may not write also, that is fine. So ultimately e prime minus e, that value see, it is equal to minus RT ln 10 to the power 6. Okay, now ln 10 to the power 6, you can write it in this way, and the value of ln 10 is 2.303. So ultimately what we are getting, this will be equal to minus RT into 6, 2.303. That means 6RT 2.303, and with a negative sign. So as we have from the explanation, we have already seen these two not possible because these two are positive. But among 1 and 4, correct option will be last. Any doubt? Should I repeat? Here also we have a plot, and here in the y-axis we have log k, x-axis 1 by t, and this plot of rate constant versus 1 by t for 4 different reactions. Now, which of the following orders is correct for activation energies of this reaction? So for the first reaction, it is EA, EB, EC, and then sorry. Okay. Now these are the 4 activation energies for 4 different reactions, and we have this plot where all these 4 reactions, that is for individual 4 reactions, we have the corresponding line. Now here we can see that the line is straight line, that is fine, and there is also intercept because lines are not going to origin. For example, if you just extend this line, it will cut somewhere here. That means it will be the corresponding value of intercept for B, that is second reaction. Similarly, if you extend this line, it will be the intercept for the reaction D, that is the last reaction. Fine. And another thing is that here from the plot it is clear that slope is negative. Okay. We will again use Arrhenius equation. Fine. And here I will omit this A because when you are considering general expression, as for the first reaction we have already considered EA, so we should not write here EA. Okay, so I am omitting this subscript. Now taking log both side, it will be log K, and in the right hand side it will be log A minus E by 2.303 RT. Why 2.303? Because it is log, it is not ln. Because if you take first ln, it will be ln K, then ln A minus E by RT. But if you want to convert it to log, then ln is actually equal to 2.303 log K, then 2.303 log A minus A by RT. Now divide each term both sides by 2.303. So ultimately what equation you are getting? Basically you are getting now this equation, right? Now if we compare this equation with the straight line equation, which is having intercept y equal to c plus mx. See, this equation we are seeing it frequently. We already have used this equation once, right? So this is the intercept, that is c, but we are not interested in intercept because we are interested in the slope. Because in the slope, that is m value, this slope is actually minus E by 2.303 R, because if you compare these two equations, X is 1 by T. Okay, so rest of the part will be slope, that is M. Now just forget about the negative sign, consider the numerical. So from the line it is clear that which line is maximum steep, that is steepest. Which line is steepest? It is the line. Can you tell me which line is here steepest? It is for C. Okay, that means here the value of activation energy for the reaction C, that is this one, it will be maximum, because this line is steepest. And another way also you can easily understand, when you are extending this line, intercept is maximum. That also another way you will be able to understand, in which case the slope is maximum. All the slopes are negative, that is common, because when slopes are positive, the graph will be, that is plots, lines will be like this, but when it is negative, it will be like this. Fine. So that is why here all are negative, but numerical value, that is maximum for C. After that it is A, because when you are extending the line A, it is cutting somewhere here. Then it is for D, because it is cutting here, and the last one is for B, because it is having the minimum value. So this is the order C, A, D and B. This is matching. Any doubt? Should I repeat? So in this plot, all the slopes are negative, but just compare with the previous problem, that is, I'm talking about this problem. Here you can see the slopes are positive. In both cases, it is matching with the equation type y equal to mx plus c. But in this problem, it is positive slope, and the problem that we are just discussing, it is negative slope. So I hope it is clear the difference between positive slope and negative slope. Any doubt?
No, ma'am.
Decomposition of A in a rigid closed vessel. This is the reaction. Both are gaseous. Follows first order kinetics. When we have started the reaction, then it is a mixture of gas A, and there is also presence of inert gas. Inert gas means will not take part in reaction. That is why it is inert. Fine. Initial pressure was 4 atmosphere, and at the end of reaction, that is after 20 minutes, not end, that is just after 20 minutes, pressure is now 6 atmosphere. It is high, but don't think it is initial pressure and final pressure. And if you are thinking that why the pressure is increased, because after reaction the pressure should decrease, just like concentration we have seen. But see, it is pressure, it is not concentration. And if you look at the equation carefully, from 1 mole of A you are getting 3 moles of B. Both are gaseous, so obviously pressure will increase. So 6 atmosphere, this value that you are seeing here, this is basically the total pressure of the reaction mixture, where both A and B both are present, and also the inert gas which is not taking part in the reaction, this gas is also present. Now from this universal gas equation, that is PV equal to nRT, when it is, as it is mentioned, equimolar mixture of A and X, that means number of moles for A if it is Na, and number of moles for X if it is Nx, these two values are same. Okay, so when other conditions are constant, that is if temperature, V and volume, R is already constant, all these are constant, then P is proportional to molarity. That means pressure for A, that will also be equal to pressure for X. So when you are saying that initial pressure is 4 atmosphere, this is actually PA plus PX equal to 4. So PA plus PX, this is basically 2 PA because both are actually same. So pressure of A is 2. Is it okay? Now we know what is the actual pressure of the compound which is actually taking part in reaction, because X is not taking part in reaction. We are not interested in X, only in A. Next we will write the equation. Initial pressure 2 atmosphere, and remember when gaseous molecules are there, concentration and pressure, these two will be treated as if it is analog. Okay, so instead of concentration, now we will write pressure terms. So initially it is 2 atmosphere for A, and for B it is 0 because reaction not started yet. And at after T equal to 20 minutes, the concentration of A, suppose it is 2 minus X. So when it is 2 minus X, A is related to B, 1 is to 3. That means this will be 3X. So total pressure will be 2 minus X, that is after 20 minutes total pressure, 2 minus X plus 3X. And remember, final pressure after 20 minutes, it is mentioned 6 atmosphere. But we have to be careful because X is not taking part in reaction. So it will be present intact before reaction and also after reaction. So this value 6 atmosphere that you are seeing, it is actually the pressure of A plus B as well as X. And X pressure we know it is also 2 atmosphere. So what we will do, if we want to express only the total pressure of A and B, that is static material and product, not X, because X is not taking part in reaction, we have to deduct the value 2. So this is ultimately 4, and here 2X equal to 4 minus 2 is 2, X is 1. So now we know what is the value of X. Okay, and it is asking finally that the time required for 75% reaction of A. Okay, but see, if we want to find out what is the time required for this amount percentage of reaction is already complete, we have to use the equation. Remember, for first order, which equation we use? We use KT equal to 2.303 log initial pressure. Here I will write pressure, not concentration. Pi divided by P, that, or you can write PT. Fine, that is final pressure. Okay, better T means total, so better I write PF, that is final remaining pressure. So this equation we have to use. So when we are saying 75% reaction is complete, then Pi will be 100 and PF will be remaining amount. Now remaining amount is 100 minus 75, because 75% is done, 25% is under. You have to write 25 here. But you do not know what is the value of K. So first you have to find out what is the value of K. Then only you can put it in this equation. And to finding out the value of K, now we will take the help of this equation, because here it is mentioned 20 minutes taking, and we also know what is final pressure. Final pressure is 2 minus X. Now we know the value of X. So remaining amount of A, that is 1 atmosphere. Okay, so this equation first we will use to find out what is the value of K. 2.303 divided by T. T is 20 minutes log Pi is 2, because initially pressure of A is 2, final is 1. So it is basically log 2. Log 2 value if we put, finally you can also keep the reaction equation just like this. You don't have to do any calculation. In this way you can save time also. Now again I am writing the same equation. But now I will write 100 divided by 100 minus 75. Okay. Now we have to find out T, not K. K we already know. Now put the value of K. So this is K. Now K, it is in denominator, so it will be reverse. 20 divided by 2.303 log 2. This is the value of K. Now we will write the rest of the part. 2.303 log 100 by 25. 100 by 25 means log 4. Now log 4 means log 2 to the power 2. These two will be cancelled. You can bring 2 before log 2 will also be cancelled. Ultimately it will be 20 multiplied by 2. That means it is 40 minutes. Which option correct? Option C. Is there any doubt? Should I repeat it once more? So first we have to find out the value of rate constant. Then again using the same equation, we will put the value of K, which we have calculated in the past equation, and we can get the unknown value of T. That is what is the time required for 75% consumption of initial that is starting material, which is A. Okay. Any doubt? Consider a first order gas phase decomposition. A 1 mole A, all are gaseous, converted to 1 mole B, 1 mole C. Initial pressure of the system, that is before the reaction, it is decomposition reaction, Pi. After the lapse of time T, now the total pressure of the system increased by X unit and it became Pt, that is total pressure. We have to find out rate constant K for this reaction. We have 4 different expressions for rate constant K in option A, B, C and D. First we will write this equation. Remember, this is gaseous equation. Okay. Initially the pressure is Pi. B and C, these two are not present, so I am writing 0 when time is 0. When time is T, now some amount of Pi that will be consumed. So suppose the remaining amount is Pi minus P. So the amount of B, that will also be P. Amount of C, that will also be P. Okay. Now total pressure, just add all these values. Pi minus P plus P. So ultimately it will be Pi plus P. Now total pressure is actually Pt also. So this value is equal to Pt. So P will be equal to Pt minus Pi. Up to this part, any doubt? Next. Now we will write the first order kinetics, the corresponding equation. Kt log initial concentration, which is Pi, and remaining amount of A. See, this is actually Pi minus P, isn't it? So we will write here Pi minus P, remaining amount. Now what is the value of P? It is Pt minus Pi. So Pi minus P, this is actually Pi minus Pt minus Pi. That is, I am putting the value of P here, taking the help of this equation. So ultimately it will be 2pi minus pt, because minus minus will be positive. So ultimately the value of k 2.303 pi, and now in the denominator we will write this one. So tell me, it is matching with which option? Which option is correct? Here the options are not given properly. It is actually like this. Okay, log is for both the term. So it seems as if it is log pi divided by 2pi plus pt, but that is not the case. It is log of pi divided by the quantity that is given. Okay, so log is common. Any doubt? Which option correct? Tell me. Look at this expression carefully and compare with the options. Any doubt? This one is matching, isn't it? Here in the denominator 2pi minus pt. So here we have not even used the term x. That is not required. Concentration of R for this reaction R to B was measured as a function of time. So concentration of R in molarity, all these values are given and the corresponding time. So when it is initially, that is t equal to 0, then the concentration is 1 molar. When time is 0.05 in minute, then the concentration gradually decreasing. When it is 0.12, concentration is 0.40, and when the time is maximum, obviously the amount of R is now minimum. So gradually the amount of R, that is the starting material, it is decreasing with time. So from this information we have to find what is the order of the reaction. Okay, question clear? So this is the initial concentration as if it is R naught. Fine. So the difference between R naught and the concentration of R at time t, this difference is basically 1 minus 0.75 for first one, then 1 minus 0.4, 1 minus 0.1. Okay, for different different times. So this is 0.25, 0.6, 0.9. Okay, so this is the change in the concentration of R. Now this value, if I consider x, fine. So del x divided by del t. Now for the first observation, it is, that is observation number 1, this is number 2, this is number 3. So for 1, it is del x value is 0.25 and del t is basically 0.05 minus 0, because initially it is time 0. So basically it is nothing but equal to this direct value 0.05. So this value is 5 after calculation. For the second one, del x by del t, now we will write 0.6. This is 1, this is 2, divided by 0.12 minus 0. This is also 5. And for the third one, now it is 0.9 divided by 0.18 minus 0.10. This is also 5. So from this observation, what it means? It means rate of change in the concentration of starting material that is not dependent on time, because it is always same. So it doesn't matter what is the time, this value is always same. And this happens for which order reaction? Any idea? That is, if we draw, this is actually rate, right? If we draw rate versus time, that means it will be parallel to x-axis. That is, x-axis means time is present in x-axis. So remember this graph. Let me so see here, the nature of the graph is rate is minus dAdt, that is actually del x del t, that is equal to constant. And this is possible only when order is 0. That means when you have drawn rate in y-axis, time in x-axis, the value is not changing with time. It is always 5. So that means it is 0 order reaction. This is the answer. Any doubt? Should I repeat? This will be the last question. For a certain reaction, there is a plot C0 minus C divided by C against time. We are getting straight line. Nature of the plot is straight line. What is C0? What is C? C0 is concentration when T is 0. C is the concentration when T is T. So here we are getting a straight line. We have taken time, x-axis, y-axis, C0 minus C divided by C. And the nature of the graph is straight line. Okay. Now, C0 minus C divided by C. This is, if we write it equal to KT, you can find similarity with the equation y equal to mx, right? Because it is straight line. Though it is not mentioned whether intercept is present or not, but you can take the simple equation, which is straight line equation, which is going to origin, going through origin. Okay. Here m is constant, t is x, and y is this total quantity. Now, if we write this equation in this way, that is C0 by C, C by C, then KT. Now C0 by C minus 1 KT. Okay. Now if I divide both sides by C0, then what will happen? What I am doing, I am dividing both sides by C0. It will be 1 by C, 1 by C0, KT by C0. Okay. Now can we find any similarity of this equation with any specific order of reaction? Because here we have options: third order, 0 order, first order, second order. Okay. Now C0 is initial concentration, which is always constant. So this part is basically constant. So as if it is K prime, that is new constant, into T. Okay. So this is the expression of second order reaction. Remember, this type of expression we have already seen, equal to constant into T. So this is the expression for second order, which is clear. So that means which option will be correct? Second. Here it is asking the order of the reaction. We have options 3, 0, 1, 2. So as it is matching with the expression for second order, so it will be option D. Any doubt?
No, ma'am.
Okay, and regarding the whole class, today we have discussed only problems. Should I repeat any part? So if there is no doubt, we can end the session here. Thank you for listening.